Hi guys, Nick from HiFi Collective here. Today we're going to be moving on from the revealing of the World Audio Design 300V PSC. So last time I was telling you about the design and the valves and everything. So we bought these second hand. We've been told they work, but do they work? Let's find out. There's lots of different test equipment you can use. We have a signal generator, which is this, and we have a scope. You don't really need those to do these kind of tests, but as we've got them, we're going to use them. So what I like to do just to get going is I've got the signal generator. It's on sine wave, what it is now, and it's at 1K, so I always use about that, 1 kilohertz. So I'm just going to have a look at the trace just to make sure the scope's good. Don't know if anybody's used the scope before, but this is the volts per division on the y-axis, and on the x-axis, there you go. There's the 1 kilohertz waveform. It's a bit dodgy because I'm just holding it like that, but it's just to show it works. Cool, so we're going to use that as our trace. So here we go. This is one of the monoblocs, 300B, parallel single-ended. We put in some electroharmonic golds in. We've got electroharmonic, just the standard ECC 12, and then we've got Sylvanian 12AU6, and then a 5U4G, just a Russian tube. So not an expensive set of tubes, but great for this particular job. IEC input there, goes and slips in the back. So let's get it up so we can have a look inside. So you can see it is a bit messy in there. I mean, worth having a good look around before you turn on, just to make sure there's nothing touching and some other contact that it shouldn't be touching, or if there's any dry joints. Well worth going in with a pair of pliers. You know, just give the wires a little wiggle, make sure they're all good, all looks fine. Components look. I mean, you can see how tarnished these are. I mean, this amp's about 10 years old, so it's seen some action. I mean, they'll be fine. They're just discoloured. There's a lot of juice goes through. They're the cathode resistors. So obviously with this audio note, it's a copper case and it's not insulated. So you want to make damn sure that the lead outs aren't touching the case. I mean, they're pretty close, but they're okay. Signal wire. The valve base is touch messy. Yeah, they're okay though. One thing I noticed when I was putting the valves in, they're very loose. Some of these valve, you know, that pin there isn't great. I mean, there's contact being made, but you'd think you'd probably replace those. So yeah, I'd turn it on in that condition. It wouldn't be an issue. I mean, ideally you'd have a variac. So variac receives AC voltage in, so you take it off the mains, and you can crank it up from 0 volts AC output up to 230 or however much you want to. So that there's no distress there. It's not like a massive surge of voltage coming into the amp. You're just controlling it. So always a good thing to have, but we haven't actually got one. Don't worry about that. Take the risk. So here's the circuit of this kit here. Now the thing with switch on is you want to locate the point where most of the power is going to. So you'll see here, this point here, so it's after the choke, it says to point A. Now point A feeds the 300B output valve, so I know the majority of the current is going to go that way. So I want to attach a test point there, because as it's valve rectified, you know when you switch on, there's going to be quite a big surge. So it should be about 400 volts there. So I know when I switch on, it's going to be about 500 volts, but once the heaters of the valves warm up, they will start conducting. So that will drop rapidly. If it stays at high voltage, you know there's an issue. The valve's not conducting. So I can identify this point here. There's the choke here. So, and there's the reservoir caps, which is upgraded. So you basically want to feed off. So that's going, he's used a dropper resistor here to bleed off some of the voltage. So yeah, you want to test here, this point here. So that's coming off the choke there to the first big cap there. So I'm going to put the leads there. So using a multimeter, just using this cheap one I've had for years and years. You need to connect to an earth point, which I will do. So here, make sure that isn't touching anything because you've got your IC mains coming in here. And then the other end, I always like to use crop clips for this first contact because you can turn it on and step back. Yeah. So there you go. Another thing you need to consider is that all valve amps like to see a load for a speaker. So we're going to use an 8.2 resistor from the start, and we'll move over to a speaker later. So you've got your speaker host here. That's cool, can't reach the other one, so we're going to use crop clips again. Like that. Not really worried about the input, we don't need anything there at the moment because we're just checking voltages. The lead pops in the back there, make sure it's off. So it's off there. Yeah, obviously lots of, just be safe here, don't do anything stupid. Don't go in putting your hands in, touching things, you're going to get a shock. So I'm content that I can turn it on now and see what happens. So if you just focus on your output voltage, I know on switch on, big surge, so that'll rise quite dramatically once the rectifier valve starts conducting. So also listen out, if you hear any kind of weird sounds, you know there's something's going wrong. So switch it on. You can hear the hum of the mains transformer. Look, it's gone up to 530, 543. So, but now it's dropping. Oops, going up again. So it's settled down now. So it's 422. Now the circuit suggests it should be 400 volts. So slightly over the top, but that could be a result of a high mains voltage, which we probably have here. The UK is supposed to be 230 volts, but it can be anything from 220 to 250, I've known. Now, the guy who I bought this off has obviously tried to reduce it. He's put a 47R resistor in here, which is an 11 watter. So he's basically fitted that in here. So he's trying to reduce the voltage. But you can increase that to get it down to 400. But so that's fine, it's quite stable that. So we turn it off, because now we want to go around the test points. Also a good idea, when you turn it on, to have a look at the valves and see if they're lighting up. But I reckon they would be, because we're getting good voltage coming through. 300 Bs, got their filament right in the inside, and sometimes you have to have a dark room just to see it. So 5U4G will have 2 dots of light at the top, and now the 6U6 is quite tricky to see, but you have to look at it anyway. Just keep your eyes peeled. So now we're going to do. You can see here that even though we've turned it off, there's a residue voltage sitting here. Now that will be because one of these electrolytics that are part of the power supply is holding voltage. So I would basically just discharge it at an earth point. So there, that's connected to chassis earth anyway. So now if I go back, I know it'll be 0 because I've discharged it. Cool, so get rid of that. So now, we're just going to go through the whole circuit, make sure the test points are good. There's going to be variations because the mains voltage is a bit high here, but it's a valve that we can cope. Right, I am familiar with this circuit, so you will need to take some time just to familiarise yourself with the points you're testing. So let's go. I'll turn it back on again. So first thing you do, you look at your power supply. As I've already said, the AC voltage is quite high here, so the voltages that we'll test will be higher. So first point here is your 410 volts, which is this stack of caps here. So which is on the first part of the choke, which is this part. 434 volts, you see. So it should be 410 volts, so it's slightly higher. And then the other side of the choke, which is here, point A, should be 400 volts. So that's here, which is where we were testing earlier. That's 424. So, yeah, slightly higher, but we can mess about that later. He has put this bleeder resistor in here, but it needs to be higher to get it right. And then we're going to test point B here, which is the other side of the 15K 1 watt resistor. You can see it there, brown, green, orange. So that's there, which is 375. It should be 350, so high again. And then you've got the supply that feeds the ECC 82. So there's basically a plus 195, a minus 195, and a minus 40 volts, which feeds the bias on the grid. So you can see the caps here, this bank of caps there. So there's a bridge rectifier WO4 there. So that one's going to be 200 volts. There, which is 210. And then there's the other side of that one. And then your negative 195 is there, which is minus 210. And then you've got your minus 40 volts, which is fed off a voltage divider 100k and a 330k. You can see the 330 there, so that's got to be there. Yeah, well that's minus 45, so that's okay. That'll do. So once you're happy with that, you can move on to testing your signal voltages. So first voltage check is a 2 volt there, which is basically feeding off the 33R. 33 I know is orange, orange, black, so I can see it just there. You can see the black gate, juicy, brilliant, quite hard to find those, so I'll be using that. And I know this red lead seems to be going off to the 6U6, so the test point's there, and sure enough, we're getting 2.19 volts, which is good. The first test point's good, so you kind of know the rest of it's going to be okay. Move the range to 200. Next test point is on the anode, so pin 5 of the 6AU6. Now that's 100k, so I can see it's a 1 watt. 100k is brown, black, yellow. I can see it there. So, and it's going to be, oops, no, that's the other end. So it's going to be there. So it's 81 volts, which isn't brilliant. It's quite a way off, but believe you me, I've tested some of these 6AU6s and they were all a bit weird. Bare relations to this one. I'm going to check the next point here, which says 118. So that's 100k and it's a half watt. So I know I can see it here. There's a test point for it, and that's 125. So yeah, that's a bit worrying. That's 84. But I won't worry about that for the moment. I bet it will still work. And then we're now going to check the ECC82, which is the 2 anodes. First, there should be 195 volts. So pin 1 and 6. So you can see where pin 1 is, which is there, just goes to there. So that's 200 volts. So when you're doing the pin count, so pin 1 is the first one there, 2, 3, 4, 5, so it goes around clockwise like that. So that's pin 1, which will be 200 volts, and pin 6, which is that one? It's also 200 volts. So they're good. And then the cathodes are 35, and they're feeding off 33k 3 watts there. So that's these 2 chappies. Look a bit tarnished those. So check those. Minus 34, minus 34. So that's good. And then on to 300Bs. So you've got the cathode. This is auto biased. So you've got the resistor and the cap, and it's saying 38 volts, one for each channel. So that's what these tarnished things hit up. These are the mils resistor. So that's 41 volts, 38, 41 volts, no big, nothing to worry about really. There, which is good. So for me, the signal stuff all looks good, apart from this here, but with experience I know that I could put another 6AU6 in there and it will be different, but it will still be working properly. Right. Yeah. So we're going to put some signal through now. The fact that it's a power amp means that you're going to make sure your volumes are down from the very start. With this signal generator, just turn it down there on the amplifier bit, but there's still going to be a bit of signal going through, and you will hear it go, which is 100 hertz. So I'm going to shove the signal in there. You can hear that kind of whine. That's the actual, you can hear the lamination, the output transformer, that's what you're hearing kind of now. And then you've got this, to look at the output, you've got the cables here. Of course, oh, it wasn't like that, did it? What's anything wrong there? Oh yeah, sorry, got the leads the wrong way around. So, let's put that there. And that one there. And you can see on the scope, you've got your 1 kilohertz signal. Then we're going to crank her up until we get a bit of a... If you look at the peaks of the actual thing, see now it's starting to round off and clip there. See it clipping there? So you kind of know that it's about there. That's good. So 1, 2, 3, 4, 5, 6.8 divisions. Let's turn that down. So you know that it's 5 volts per division, so 6.8. That's your RMS voltage, or your peak to peak actually, not your RMS. But we can work it out later to give us a power yield. So that's that. All looks good, signal looks okay. I'm going to show you what the humbucker does. Okay, so this is the other monobloc. You might have noticed there's a slight change going on. This is an orange drop 0.22 cap, which sits on the circuit here. Obviously a key component. Now, unfortunately, I had an issue with this amp because it was just screwing up all the voltages, which meant this was leaking. Now this is about, I don't know, 12 years old, and it's one of the old audio note paper and oils that had gone funky. Now, on the other amp, he has a new Mylar version, which obviously works fine. So I kind of had an idea that that could be an issue. So I swapped them over with this one, and it seems to be fine. So everything else tests okay. I just want to show you about the humbucker. So switch on. Let's give it a minute. Because this amp's a lot quieter than the other one. Again, if you can hear it, everybody be quiet so we can hear the hum. Right, can you hear that hum? So that's the humbucker not in the best place. So we'll turn it the other way. Dirty little contacts of this part. So the hum's pretty much gone. I mean, I would change these pots, they're just filthy. The only problem is you can't actually get inside them, but we have some new AB electronic ones which I'd go for. So it's pointless spraying anything in because you can't get inside the wiper. So there you go. So that, which is obviously the lowest hum level as well. The thing with directly heated triodes, you can put a DC voltage on the heaters that reduces the kind of noise that comes through. But the only issue with doing that is you kind of decrease the life, because a nice gentle up and down wave is less distressing than straight line, I'm on all the time kind of thing. So there you go. So next point of call for us on this project is to think about what we're going to use for an upgrade. So next video I'll basically go through the circuit and talk about components I feel would be best in what position. See you later.